We can maybe think about skipping stuff as we get closer to the end of the 12 sessions. Okay, can you read this? For how many positive integers a, is it true that a squared is less than or equal to 2a?
Yes. Well, let's see. 1 would be less than or equal to that.
Okay.
2 would be equal. And then, yeah, 4 would be wrong, and so would more than 4.
Okay. So which is the answer?
Less than or equal to.
Mm-hmm.
Well, see, it can be either 1, B, or C, can't it?
No, in this case, how many basically is saying what's the maximum?
Oh, 2. Oh.
2. Right, exactly.
Yeah, I wasn't reading it.
Well, you figured out that it was 1 and 2, which is correct. Okay. Okay, on this one, A is less than B, and they're both greater than 0, and they're both less than 1. So indicate which of the following are true, and here you could have any combination of answers.
Okay. I guess on this one I need to pick numbers, although they be fractions.
Okay. So what number do you want to pick for A and B?
I guess 1/4 for A and 1/2 for B.
Okay. Good choice. And I don't think it matters, since these would all have to be the same even if you picked 1/10 for A and 7 or 9/10 for B. It would not change any of these. So this is one of those cases where picking numbers you don't have to worry about whether you accidentally picked correct numbers.
Okay.
Okay?
Okay, well, it looks like A would be, let's see, 1/4 minus 1/2, that's true.
Okay, that's negative.
And the bottom one would also be true, or B.
B would be true? When you said the bottom, did you mean C or B?
No, I meant B.
Okay. B is true.
Yes, and then
Got nothing
C,
but positive numbers, so.
oops. And C would not be true.
Very good. It's easy to make the mistake. When I first looked at this, going through it very quickly, I actually made a mistake on C. I put 1/2 minus 1/4. Yes, that's positive. And the reason that's wrong is because it's 1/1/2 minus 1/1/4, which is negative, because that's 2 minus 4 equal -2. So it's easy to fall into the trap that I did when I did this quickly by making 1/B 1/2, which it is not.
And then especially when you're in a hurry, it's easy to do that.
Yes, yes. And there is algebraic ways to analyze these, but I personally think that if you can plug in numbers and be certain that it doesn't matter which numbers you plug in, that's probably the better way to do it. The product of 4 consecutive integers is equal to one of them. What's the largest possible value of one of the integers?
I don't even know where to start on this one.
Pick 4 consecutive integers.
Well, you could have 1, 2, 3, 4.
Is the product of those equal to any of them?
No.
The product is 24. That's not equal to 1, 2, 3, or 4. So immediately I notice something peculiar here. How do you get 4 consecutive integers whose product is equal to them? Because clearly if I make it 10, 11, 12, 13, that's the same thing. The product's going to be a huge number. It's not going to be 10, 11, 12, or 13. So what number needs to be in my list?
Oh, you could have 0.
That has to be in the list. It's got to be one of the 4 numbers, because without 0, no 4 numbers are ever going to be equal to one of them. The product is never going to be equal to 1. So what's the largest possible value of one of the integers? Here's my integers.
So yeah, 3.
3 is the largest possible value, yes. And the point that's being illustrated here is that when you have a product of anything equal to 0, one of them has to be 0. Now, there's a further point here, but that's the important one. Is that if you have numbers, if I have A, B, C, E multiplied together, and that's equal to 0, that tells me that one of these 4 letters has to be 0.
Okay.
If I had 26 letters multiplied together and they were equal to 0, it tells me one of them has to be 0. You cannot achieve a 0 product unless 0 is one of the multipliers. Okay, number 4. At 3 a.m. the temperature is 13 degrees below 0. By noon it was 32 above. What's the average hourly increase in temperature?
Well, let's see. We went up 19 degrees in 9 hours.
Okay, be careful with that. We're going from 13 below to 32 above.
32 above. And of course, they had that trick answer in there too.
I know. They are very tricky for sure. In fact, they had it in there twice. Usually when you see something like that twice, that's one of the answers. In fact, that's one of the clues I used to give people. That if you see an answer in there twice, think hard about that. That's one of the likely ones, but I was wrong on this one. It's not true.
Yeah, in this case, they really tricked us.
Yeah. So what's the difference? How much did the temperature rise?
It went up 45 degrees.
In how many
in
hours?
9 hours. So 5 degrees.
Yeah. Now, let me just point out something here. When you go from 3 a.m. to noon, you might wonder whether this is a situation where you have to add 1. You know, if I want to find out how many rows are between rows 3 and row 48, if I count the 2 rows, row 3 and row 48, then there's 46, because I take 48 minus 3 and I have to add 1 to it.
Okay.
That's if it's inclusive. Well, this is a completely different problem if we're going from 3 to 12. We're going from 3 to 12, but if I'm concerned of whether 9 is the correct answer or not, well, just go from 3 to 4. If I go from 3 a.m. to 4 a.m., I know that that's 1 hour, and if I subtract the 2 numbers, I get 1. So I know that there's nothing else I have to do. So that 12 minus 3 is definitely the number of hours that have passed by. And this principle that I use here is basically bringing it down to small enough numbers that you can count on your hand almost. How far, in other words, if I say how many rows are between 3 and 48, I don't have time to go, well, let's see, there's 3, 4, 5, 6, to come up with 46 as the answer.
Right.
But what I do have time to say is, well, how many rows would there be between 2 and 4? Well, there would be row 2, there would be row 3, and there would be row 4. So there would be 3. But if I subtract those two numbers, I get 2. So here's a situation where I know I would have to add 1.
Okay.
Because I can do it all on my fingers when it's small. The only time I have to rely on a formula is if it's big. Big numbers. Okay? Yeah, the GRE loves the number theory. They tell you at the beginning that all the math you ever needed you learned at 9th grade, but that's not quite true because most people don't get this kind of number theory. And the theory that they put on the test, I'm not sure we learned that in high school. It's something you almost have to work out. It's more logic than it is anything else. But there are some basic stuff you need to know. So if A and B are negative and C is positive, which of the following statements are true? Indicate all such statements.
Okay.
Is A minus B less than A minus C?
No. I don't.
Well,
Let's see. A would be negative. B would be negative, but since we're subtracting, it would be positive.
okay. How did you got the right answer. How'd you get it? You didn't plug in numbers, right?
No.
Right. This would be a dangerous one to pick numbers because there is such a large leeway between, I could pick minus a million and minus 1 for B, and it might matter on the answers to these. So I would be very reluctant to pick numbers. It's not like that other problem where we knew that A was less than B and they're both between 0 and 1. This is a little different. Regardless of how you did it, you got A right. The way they show it in the book, I'll show it real quickly, is if B is negative and C is positive, then we know that B is less than C. Okay?
Okay.
Well, if B is less than C, then minus B has to be greater than minus C. In other words, we divide both sides by a negative 1 and reverse the inequality sign, which is what you have to do. And now I can add A to both sides, so there's a true statement, which is the opposite of what they say. Okay? About B. If A is less than B, then A over C is less than B over C.
Now that one I almost feel like you would need to have numbers. Well, no, you wouldn't.
Not really. There's a pretty, we start with this.
So that would be accurate.
B would be true.
Yes.
The reason is because we know C is positive, we can divide both sides by C without affecting the direction of the inequality sign, only because we know C is positive. If C is unknown, if C is just some variable, then this would not follow. Because if C might be positive or negative, then we wouldn't know whether A over C was less than or greater than B over C. But since c is positive, we can divide both sides of this inequality by a positive number without worrying about the direction of the inequality sign.
Okay.
So that would be a true. Okay. Is 1 over b less than 1 over c?
Yes.
And that is true because we know b is negative, so 1 over b is negative. And we know c is positive, so 1 over c is positive, and a negative number is less than a positive number. All right. X is between minus 7 and 7, or equal to, and y is between 0 and 12, or equal to those. What's the greatest possible value I can get from y minus x?
19.
Very good. 7 to the a times 7 to the b is equal to 7 to the c divided by 7 to the d. What is d in terms of a, b, and c?
Okay, this one's going to take me a few minutes to work out.
Okay, help me, or why don't you talk out loud, and where are you starting?
Okay, well, let's see. What is d? Well, I would multiply both sides by 7d.
Okay,
Or do I want to just get rid of the 7?
Let's use our rules of exponents. Word
Okay.
7 to the a times 7 to the b can be rewritten as what?
7ab.
7 to the a plus b. In other words, if we're multiplying same base, different exponents, we add the exponents. If we're dividing same base, different exponents, we subtract the exponents. So I can write the right side of this equation as 7 to the c minus d. So now I have this, and if I have the same base to an exponent equals the same base to a different exponent, I can equate the exponents. So now I can say a plus b has to equal c minus d, and now the problem becomes simple. What is d in terms of a, b, and c?
It's going to be c minus a minus b.
Okay, which is this answer here.
Well, you made that a lot easier.
Yeah, I'm not sure what happens if you multiply it times 7d. Actually, that will end up working. You'll end up then combining all three of those into 7 to the a plus b plus d equals 7 to the c. So you would have a plus b plus d equals c. You'd eventually get there also. But the key, of course, is that rule of exponents. Here, let's just go through the three cases that are key. X to the a times x to the b equals x to the a plus b. X to the a over x to the b equals x to the a minus b. And the third one might not be that obvious, but I think you know what it is. If I take x to the a and raise the whole thing to the b power, what is that?
That's a times b.
Okay. Notice that this is one level less mathematically than that. Where I have multiplication, I do addition. Where I have division, one less level mathematically is subtraction. And when I have exponentiation, one level less is multiplication. Okay, number 8 is another symbol problem. This is a little more difficult. These are even hard to understand, so it's good that we're doing these, because once you do one or two of them, they make more sense. If the star, we'll call this a diamond, if the star and the diamond can be replaced by either a plus sign, a minus sign, or a multiplication, how many different values are there for this expression? And I will give you a hint, this is a counting problem. And by that, counting problems, usually you want to lay out all the possibilities and figure out which ones, what their values are.
Okay, so what we're doing is it would be 2 plus 2 plus 2.
One possibility. What's another? In fact, the way to do these is to pick one symbol and do all combinations with that, and then do the next. In other words, we've already got the 2 plus. Let's do another 2 plus. And this could be minus. That's different. And the other one would be 2 plus 2 multiplied by 2. And what I've done here is, okay, I've come up with all of the possibilities of having this be a plus.
Okay.
Okay. Now let's come up with all possibilities of having that be a minus. So I could have 2 minus 2 plus 2. I could have 2 minus 2 minus 2. And I could have 2 minus 2 times 2. And then there's 3 more, because this first symbol could be a multiplication. So I could have 2 times 2 plus 2. I could have 2 times 2 minus 2. And I could have 2 times 2 times 2. So there are the 9 possible ways that you can combine those.
Okay.
And you'll notice there aren't any others. And when you do these counting problems, you want to be very methodical. In other words, you don't want to do a 2 plus and then a 2 times and then because you won't be able to keep track of how many you've done. By methodical, I mean start with making that column pluses and then do all the minuses and then do all the multiplications. And then you will cover all the combinations. Notice that you can't think of another combination here that I haven't already put down. They may be in a different order, but I've covered all of the different combinations. So now let's write out what each of these is equal to. This seems like a lengthy way to go, but it's the only one I know of because we don't have different values. In other words, the answer is not 9. How many different values? Some of these are going to be the same. This is 6. This is 2. What's this one?
8.
Actually, we do the 2 plus times 2 first.
Yeah,
so we have to use PEMDAS. Okay, so this would be 6 because we'd be adding 2 to 4. Okay, this we can do them in any order. So this is 2. This is negative 2. This is negative 2. This is 4 plus 2. That's 6. This is 4 minus 2. That's 2. And this is 2 times 2 times 2, 8. So how many unique values do we have? Well, there's a minus 2. There's a plus 2. There's a plus 6. And there's a plus 8. 4 different values.
Okay.
Okay? On the same line, how many different ways can I write the letters A, B, C? List them for me. Rather, we don't want to necessarily use combinations or permutations, although we may run into problems where we have to use those. But for now, we won't worry about it. But I've got the letters A, B, C. List all the ways that I can write those in different orders, starting at the top.
Okay, we do
Okay.
and ACE.
Okay.
CAE.
Okay, now see that I would keep the pattern. I want to vary from this pattern at all. We've done A as the first letter. And done all the combinations you can do with A as the first letter. So let's try B as the first letter.
Okay.
We can do BAC. What else can we do?
BCA.
And finally,
CAB and CBA.
so there's those 6. But this is what I'm saying is try to be methodical. Use the A's, then do the B's in that column, and do the C's in that column.
Okay.
And that, I think, works the best to be all-inclusive. Because if you kind of bounce around, you won't know if you've got them all. All right, let's see. I need to go to the next page. This is 005. Ugh. I hope this doesn't give you a headache trying to read this. Here, I apologize. I try to keep that camera as steady as I can, but I guess I either need a better camera or a steadier hand. Or a tripod, maybe. That's probably what I need to do, is figure out how to set it up on a tripod so it's not dependent on my steady hand. A number is terrific if it is a multiple of 2 or 3. How many terrific numbers are there between minus 11 and 11?
So if it's going to be a multiple of 3, then does it have to be a multiple of 6?
No. In other words, 3 would work. 3 is a terrific number because 3 is a one-time multiple of 3. And negative numbers don't really matter. In other words, negative 10 is a minus 5 multiple of 2. So for your analysis, let's just deal with positive numbers. And we know that, well, that's a little dangerous now that I think about it. This is pretty much it's a counting problem. It can be sped up if you recognize that positive numbers and negative numbers are going to be the same. But if I wanted to go to the trouble, I could write out all the numbers, and actually it really actually helps to do it in this problem, and you'll see why when we're done. Which of these numbers are multiples of 2 or 3? Negative 10?
Yes. Yes.
Yes.
Yes.
Yes.
No.
No.
Yes.
Yes.
No.
No.
Yes.
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 No.
No.
I'm going to put a big diamond over that one. We'll get back
Yeah,
to that.
I was going to ask you about that.
Well, that's very interesting. I didn't pick it either until I saw their answer. Okay, and then going on, yes, yes,
Yes.
yes,
Yes.
yes, 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 yes. 1, 2, 3, 4, 5, 6, 7 times 2, that's 14. So it would appear the answer is 14. 14
Except
isn't
that-
on there. Since 14 isn't on there, and we're sure that it's at least 14, 0 must count.
Okay.
And the only reason we know is because they didn't put 14 on there. If they'd have put 14 and 15 on there, I wouldn't have picked 0. But let's think about 0 for a moment. Is 0 a multiple of 2 or 3? Well, when you think about it, yes, it is. It's a 0 multiple of it. In other words, 0, to be a multiple of something, the reason 6 is a multiple, well, let's take 10. The reason 10 is a multiple is because it is 5 times 2. Well, 0 is a multiple of 2 because it is 0 times 2. So they do count 0. And this may be the first question I have ever seen on a test that talks about 0 being a multiple of other numbers. So I wouldn't have actually known the answer to this, but I could have figured it out merely based on the fact that I'm quite certain there's exactly 14 or there's 15, if I don't know whether 0 counts or not.
I know, I don't think that.
Well, since 14, no, but there is a certain logic here. I'm not sure that that's a commonly understood distinction about 0, but the fact is 14 isn't on there.
Right.
And we know it's not less because I know that all of these numbers are multiples of 14 or multiples of 2 or 3, so it has to be 15. In other words, 0 has to count. There's no other. It's like Dr. Spock said. If you've exhausted all other possibilities, then the one remaining one, no matter how slim, has to be the answer. Okay, here's another symbol problem. X symbol y represents the number of integers greater than x and less than y. What's the value of minus pi symbol root 2? So we want the number of integers greater than minus pi. And
Less
so
than,
let's put numbers. Let's put numbers on here. Okay, so here's our symbol. So how many integers are in there? Let's list them. What's the first one starting from the left?
one.
Actually, if we look at the number line, negative numbers are integers.
I'm sorry, I was going the other direction.
Okay? Doesn't really matter which direction we go from. How many integers are there between minus pi and root 2?
So I'm writing this in. There's 1, 2, 3, 4, 5.
Correct. 0 is an integer. 0 is an even integer. but 0 is not a positive integer, in case you're wondering.
Okay.
Okay? Your positive integers go 1, 2, 3, 4. Your negative integers go -1, -2, -3. 0 is neither positive nor negative, but it is even. It's not odd. And it's not neither. It's even. If I say list the even integers, there they are. Yeah, just what you need. The hardest problem on the page, and it's the blurriest. So here's what it says. For any positive integer, t of n.
And you know, I'm losing you.
Ooh, can you hear me? Let me turn my camera off. That should help the audio a little bit. How is it now?
I can hear you now.
Okay. Wow. I got to call GoToMeeting and figure out what I can do. I can't run my camera. I don't think I've made it through a full session with my camera. And it never gives me a problem when I first start. It's almost like it accumulates and builds up, and finally it reaches some place in the computer where it can't hold it anymore. Okay, here's what, for any integer, for any positive integer n, which means we're only dealing with 1, 2, 3, 4, and so forth, t of n represents the number of positive divisors of n. So which of the following statements are true? Is t of 5 equal to t of 7? What does t of 5 mean?
I'm not sure.
It represents the number of positive divisors of n. In other words, of 5. So how many positive divisors are there for 5? There's 2. The number's 1 and the number 5. Okay, so every number has at least 2 divisors. So t of 5 is equal to 2, because there's precisely 2 positive divisors of 5. Well, what does t of 7 mean?
It's also going to be 2, 1, and 7.
So those two are equal. So A is true. Now let's take t of 5. I'm going to have to look in my book to even be able to read this. Times, I didn't know whether that was a subtraction or multiplication, times t of 7, is that equal to t of 35? Well, we know that's 2 times 2. Well, what's t of 35?
7 and 5 come 1 and 35.
So that's 4. So that's true also. And the third one says t of 5 plus t of 7, is that equal to t of 12? Well, we know this is 2, this is 2.
No, that's not equal.
So more than 4, right?
Yes.
So we got 1 and 12, 4 and 3, 6 and 2. It's at least 6.
Yes.
Okay. And one more question concerning this on the next page, and that is, what is the value of t of t of
Oh boy.
12. Now, whenever you see nested parentheses, always start from the inside and work your way out.
Okay, and we know that 12 has 6.
Okay, so now I can write this t of, well, t of 12 is 6. So I've eliminated it down to that. Now what?
Now we have 4.
Because 6 has 6 and 1, and 2 and 3. So now we have t of the number 4. And what's that equal to?
4.
1 and
3.
4, 3. Because it's 1, 4, and 2. And 3 is one of the answers on this. So. Oh, sorry. I thought I had it on the next page. I had it on this page here. This is a little more legible. And it's the same page. It must be the angle that I'm pointing the camera. All right, 13. P and Q are primes greater than 2. Which of the following statement must be true? Indicate all such statements. Is P plus Q even?
Yes.
Is P times Q odd?
Yes.
Is P squared minus Q squared even?
Yes.
Good. Looks like you know your odds, evens. In other words, the number theory is, let's just go through it even though you know it pretty good. Even times even is always even. Odd times odd is always odd. And odd times even is always even. So 2 out of the 3. So the only way you can produce an odd is to multiply odd times odd, which is happening here and here and here. And then odd minus odd is always even. But if you have any questions about those, just plug in simple numbers. 3 minus 1 is 2, so odd minus odd is an even, and so forth. Another good principle. X is between 0 and 1. Which of the following lists the numbers in increasing order? In other words, we want smallest number first, middle number second, biggest number third.
So would I just take a number like 1/2 and plug them in?
Okay. So square root of x is square root of 1/2.
Yeah.
And x
The first one's
squared
not going to be correct.
is 1/4. Okay. So now rate these. What's the smallest number here? What's the biggest? What's the middle one? Notice that we probably could have picked a better x that would make this easier.
Yes.
What would be a better x?
That I'm not sure. Can we use one even though it says it's less than 1?
Notice that if we use 1/4, this middle one becomes much easier to solve.
Oh, okay.
The square root of 1/4 is what?
1/16.
Actually, it's 1/2.
Oh, I'm sorry. I looked at the wrong one again.
That's okay. This is something that most people miss, and we'll go over a couple other things here. So in other words, this is the smallest, this is the middle, and this is the biggest. So it goes x squared x square root of x. Well, this is the opposite of the way it would go if x was greater than 1. If x was greater than 1, then it would go square root of x, x squared, which the principle that you want to remember is that if you take a number greater than 1 and square it, it gets bigger. If you take a number between 0 and 1, I don't want to say less than 1 because I don't want to talk about negative numbers, but if you take a number less than 1 and greater than 0 and square it, it becomes smaller. Notice that if I square 1/2, it gets smaller. It becomes 1/4. If I square 9/10, that becomes 0.81. It gets smaller. If I square 1.1, it gets bigger. It's more than 1.1. So that's the principle, is that numbers between 0 and 1, when they get squared, they get smaller. When you take the square root of them, they get bigger. Notice that when I took the square root of 1/4, my answer was bigger, 1/2.
Yes.
So everything tends to work in reverse. Can you excuse me for just 1 second, Angela?
Okay.
I'll be right with you. I'll take that lock off the fence. I'll take the lock off the fence. I'll be right with you. Okay? 1 second. Angela, give me 1 more minute. Sorry.
Okay.
Stay. Sorry about that.
That's okay.
Lawn people weren't supposed to come till later. Now my dogs are going to be barking the whole session too. Okay. We we'll go an extra 5 minutes here to make up for that. Okay, we've got 7 to the 8th times 7 to the 9th, all raised to the 10th power.
And it's going to be equal to 7 raised to the 170th.
Okay, good. Okay, I'm going to need the next page. 11. All right, now every section from this point forward, all these practice sessions, oh, that was steady Eddie here, huh? What a difference it makes.
Oh, I know, those are nice.
Yeah. Every one of these practice sessions has a quantitative comparison part of it, which is good because that's a big part of the test. So we want lots of practice on these. So which is bigger here? And I would say on problems like this, the answer is not going to be list them out and multiply them together. I mean, you would get the answer that way, but there's going to be something else involved here. That's not the way that the quickest way to solve this at all.
Well, I think on this one, quantity A is going to be larger because quantity B has even integers, which would include 0.
Very good. That's exactly the way you're supposed to do it. And that in itself makes quantity B 0. So we still need to make sure that we know whether this is either positive or negative.
Okay.
But the number of odd integers, well, you're going to have -7, -5, -3, and -1. So you've got 4 of them, which when multiplied together become positive.
Positive.
And the other 4 are already positive. So the only thing we really need to know is whether quantity A is positive or negative. Okay.
And this one I'd say that it can't be determined because A could be positive or negative.
Correct. Correct. Or if A and B was 1, this side would be 2, this would be 1. But if A and B were each 5, that would be 10, that would be 25. So all I need to do is find one set of numbers that gives me a difference to be able to answer D immediately.
Okay.
Okay? And that's all I need to do. In other words, I don't need to prove anything. If I can find an A and a B where these things are, in one case, this one's bigger, in the other case, this one's bigger, I'm done. On to the next.
Okay.
The remainder, which one for 18?
And once again, I'm going to say it can't be determined.
Well, if I divide 13 by 7, what's the remainder?
6.
If I divide 14 by 7, what's the remainder?
Nothing.
Is there any way to get a remainder greater than 7 or equal to 7? In other words, the remainder is always less than the divisor. 7 is the divisor, so the remainder is always going to be less than 7.
Okay.
Okay? Now, 19, I hate the question. I really, truly hate this question with a passion. Because first of all, you never run into this. Not anywhere. Nobody will ever give you this and say, solve that. Just out of curiosity, what is quantity A equal to?
1.
Here's why I hate this problem. This is what most of us were taught. So you would do the multiplication before the division and you'd get 1. But in reality, the rule says is that if you have multiplication and division, you work from the left. So this is actually 16. In other words, we do 24 divided by 6, which is 4, times 4 is 16. But who knew that rule? I didn't know that rule.
I didn't either.
And the reason I didn't know it is because you never encounter that. PEMDAS is something that somebody made up to help people figure out the order to go in, but multiplication and division are considered equivalent, so you work from the left. Same thing with addition and subtraction. You work from the left to the right if you encounter both of those. I guess good to know.
Yeah.
Good to know if you've got a second grader giving you the problem, because only a second grader would present it like that. Everywhere else on the planet, they're going to do this. They're going to use parentheses.
Yeah, that's definitely what I'm used to seeing.
What's that?
That's definitely what I'm used to seeing is the parentheses.
Yeah, always. That's the only way a mathematician would present it. Okay.
And this one, quantity A is going to be larger.
Good. You split that into 2 fractions. There, before we do that, let me go over a principle here. Pi, right down. A plus B over C is equal to A over C plus B over C. In other words, it's the distributive property applies. But A over B plus C is not equal to A over B plus A over C. Those 2 points I just wanted to point out.
Okay.
Okay? Because a lot of people will make this mistake. In other words, the denominator has to be a single entity to be able to split it into 2 fractions. I can split this up into this and into this, but I cannot do the same if the denominator has 2 things in it.
Okay.
Ever. Okay. Let's do 21.
Okay, I'm not sure where to even start.
What do the numbers 2, 3, 4, 5, and 6 have to do with 60?
They're 60 is divisible by all of them.
Okay, and in fact, is 30?
Yes.
No, 30 is not,
Oh, it's not?
because it's not divisible by 4.
Oh, okay.
Okay, so 60 is actually the lowest common denominator for all of those. So if each of these numbers divides evenly into 60, then what must n be in order to have a remainder of 1?
61.
Yeah, that's the only thing it could really be. Or 121. In other words, also, all multiples of 60 plus 1 give you the same answer. In other words, each of these numbers that I've written could be n. But in all cases, n is greater than 60. So quantity A is the larger. And the reason I ask about 30 is because if 30 was a possibility, then we wouldn't be able to say that.
Okay.
But 30 is not divisible by 4. So only, this has to be at least 60. When you see a bunch of numbers like that and you see 60 over here, try to relate those to this number. There must be some connection.
Okay.
All right. Should we stop there?
Yes. Yes.
Okay. I think I wasted about 5 of your minutes before
No, you didn't.
with my lawn people. Okay. Let's see. I wanted to mention to you, I picked up a calculus student that's going to work with me twice a week, and he likes 9 a.m. also.
Okay.
But I wanted to let you know that if you want a specific day and the 9 o'clock is not available, I can do 10 on most days also. In other words,
Okay.
I'm not limited to just 9. Let me just look at my calendar here, and I can help direct you when you go to make your next appointment a little bit. So if we look at next week, this guy Bo took the Tuesday and Friday 9 a.m.s. So you can do Monday, Wednesday, Thursday, or the weekends. I don't mind the weekends either. And if you must do Tuesday or Friday, I could do 10 for you. In fact, let me just open those right now, and that'll give you total freedom here. Because even if I play golf, I don't usually tee off until 11:30.
Okay.
So now you've got all 5 days of the week to choose from. Okay?
Okay.
All right, sounds good. You probably noticed on our last session, I don't know if you noticed or not, but I was only able to process the second half of it. Remember, I had to reboot my computer and you logged back in?
Yes.
Well, the first half of the recording I wasn't able to convert it to a format you can read. So the only file that I posted up there was that second half.
Okay.
Today shouldn't be a problem.
All right.
Okay?
Okay, thanks.
All right, Angela. Talk to you next time.
Okay, bye-bye.
Bye-bye.